Hey everyone, thanks for joining. So today I'm gonna do a quick walkthrough of really what it takes to go from start to finish of how to design your own Tesla turbine on Fusion 360 and then how to take it to your CNC machine. I will specifically be doing it with my 6040 and using Mach 3 to run it. It should be pretty similar to most of the other things, but this is what I'll be using in mine. So let's just get started right off the bat here. You can see that we're in a blank screen on Fusion 360 and it's untitled, and I'm just going to go ahead and start. What you're going to want to do is create a sketch and set the dimension, or set the angle that, which dimension it'll be operating from. And what I always like to do is just start by making your first size of the disc. Let's go 5 inches. I really do not like seeing the dimensions on the screen when I'm building. I know what it is when I'm building it. I hate it later though because I never know what it is. But yeah, so I would just go with a 1/2 inch drive shaft in the center. Now, depending on if you want to do the old version or the new one, where you do a hub and then the hub of discs go on another shaft, or just everything goes on a shaft and you don't have the hub system, we'll just do the quick straight from the drive shaft. So still you need a inner portion of the discs that are connected together where the spokes meet. So I'm just going to go with a 0.75, nope, not 75, 0.75. So we got about, I think it's an 1/8 inch or 1/4 inch thick here. Let's see what that says. Yeah, it's 1/8 inch between. Let's go with a full, let's just do 1 inch, a full 1/4 inch in there. So then I usually start with making the first spoke, and we know we're going to go up. You could go left and build them that way, either way works. And it's just, say we know we want all of the spokes within a 1/2 the diameter of the actual disc. So when we do all of the exhaust within 1/2 the diameter, that leaves 75% of the total disc area to still be usable for adhesive drag, for a torque or for pumping. But so we've got the inside here. Go to the offset. Make the first offset. Let's just say this are. We'll go with 1/8 inch thick. So 1/16 to this to the right, and then 1/16 to the left. Get rid of the center and trim off these lines. So we've got the majority of what's going on here. Then we're going to remove that so we can do our fillet. We're going to do that. Click the line. Let's just set it to 0.15. Do the same to the other side here. Now we're going to do on the inside here. Just do the same geometry. These might come out a little skinny. I'm not saying you should do it exactly to this size. I'm just, oh shoot, what did I do to the other side? So I do 0.15. Yeah, there we go. If the dimensions keep showing up even though you've clicked on the thing on the side, and if you click it again, and it'll go away. There we go. So now we've got this basic geometry of the first spoke. I'm going to grab each one of these. Oh, not that. I say grab, it just means select each one. And you're going to come up to create and do circular pattern. And click your center point. select the center point, and then you're going to choose how many spokes you would like. If you want to do 3, you can do 3. If you want to do 4, if you want to do 5, 6, 7, you can do as many as you want. I usually just go with 6 because I like honeycomb, and it's usually honeycomb finds to be really, really strong in most applications. Not always, but generally you want eventually to pick what will not combine with the resonances of your disc when they rotate, because at high RPMs they take cymatic vibrational modes, and you can kind of tweak your spoke numbers so that those vibrational nodes are dissonant with the number of spokes, so that it doesn't add to building up where the spokes are or aren't, and you get catastrophic effects. It's not a solution for everything, but it's something, if you really want to go down that rabbit hole, you can probably play with. But we'll just go with 6 from here, and then get rid of the outer part, and get rid of the inner ones. And there we are. We've got a decent disc, we got spokes, we got the pretty large open area from a 5-inch disc. That's 0.575 squared inches per thing. There's 6 of them, so about a little over 3 squared inches. Pretty good size for an exhaust of a 5-inch disc, and you still have 75% of the open surface area here to be used for torque. Okay, so now we've got our disc. Now we're going to need a set of star washers. So we're going to copy all of these. We're going to finish the sketch. We're going to start a new one and paste them here. Alright, so I'm going to hide these dimensions and constraints. Alright, so now depending on what you want, how long you want your star washers, Tesla says to go really far past the holes. You can go really, really far, you can go short, depending on how big they are too. He says specifically in the patents that the star washers are only for creating the spacing in the center. So if you're doing the thin sheet metal like I do, you can press the dimples in the periphery here for making the spacing, and you can continue pressing them in the center. And he says specifically that the star washers are preferable, they're not indispensable, and you can use just a center hubs or a center circle that goes just about the length of the inner hub of the discs. I believe he says that it's not preferable, or it's preferable to do the star washers, because if you have the space from the hub and then you also have spacers out past the exhaust holes, the spokes with a lot of air going in them can probably vibrate. If you have really thin ones like mine, they probably have like a harmonica where they would high tension vibration as the fluid's going past them fast. But okay, we'll go to a line, do a line up this way to about 1.5 inches for this 5-inch disc. Do a 1/8 thickness here. This is if you want to just do star washers that are just little straight spokes. And again, by no means is this the proper dimensions you should be doing with yours. I'm just doing a random layout of how to put this specific geometry together. You can change if you want to increase this. Nope, not that. You want to increase the diameter of the inner spokes, or bring this down, or widen your spokes. Have at it. This is just to show you what to do to get these basic patterns on the page and work from there. So we got the first spoke going here, and we're going to take each of these pieces and we'll do the same thing we did to the exhaust pattern, or the spoke pattern. Do a circular, select the center, select how many we're going to do it over. Alright, and I'm going to take and delete all these pieces here, because they will not be used in this part, because we already have them in the disc pattern. And now, if you guys like this, showing how to do these walkthroughs, please let me know in the comments. This is something I'm going to try and start doing if you like it. Be nice to know whether I'm putting time towards it and getting good use for it. Or if you guys are getting good use out of it. Alright, so now we have both the disc and we have a star washer. And I don't know what that did. So, okay, cool. So now, let's say you've got your proper disk settings and your parameters chosen. You've got your size, you've got your star washer, and I won't go into how to make the end plates in this one. This is just simply how to cut your star washers and how to cut your discs out of thin sheet metal like I do in my videos. So from here, we're going to go to manufacture. We'll go into doing a new setup. Select model. I like to go into and select specific sketches per setup that I build in here for each thing. So this will just be specifically the sketch for the manufacturing setup for the disk. So we'll select that. I don't really usually bother with the stock box at this stage because it's really simple to get what you need without dealing with it. Alright, so there are a couple choices you can use here. I usually use a 2D contour because the thin sheet metal you can just once you get through the top of the material, you can just continue doing single cuts around because it's thin enough. You don't need to do multiple step downs with it. That's at least for the aluminum I'm using so far. I have going to be testing stainless steel here soon, but yeah. Okay, so I know I'm gonna jump right into this because I don't want to have to go through all the settings for how to make this because I will make another video on what to actually choose for your settings for your feeds and your speeds. I'm not trying to go into that in depth right now. I'm just trying to show you once you have these pocketing programs, or I believe we're specifically going to do a 2D contour packet. But yeah, so once you get your 2D, I'll just start from a new one just to show you. You get a new one, you're going to be given all of your choices for your feeds and speeds. I've been using my 2mm single flute flat. I think it's flat, but I don't know if you consider that flat. It's pretty sharp. But depending on your machine and your material, these are going to be completely different. But so you're going to want to come through and set your heights. And generally, I like to stick pretty close. However, I've been changing that now that I'm using my magnetic fixture that holds the stuff down because it's got to come up and over stuff so you don't hit it. But right now, we can use this just for a simple thing. So the passes, I don't do too many. I don't do roughing pass, multiple depths. Once you get the right feeds and speeds for the thin aluminum, it's pretty on point. I do usually use a ramping setting, but I'll show you that in the other one. But from here, you're going to want to come through and you got to select your geometry. If we're just doing the disk, what we're going to do is then select these, each one of these, each one around. Usually I like to set these things in different packages, just like all the exhaust is one operation. The drive shaft is its own operation. But to speed things up, I will make it. So for these packages, or the 2D contours, you can set it to do inside the geometry you're choosing or outside the geometry you're choosing. This specifically, you want inside. You can see the arrow will go. Sometimes when you're on this program, you can see sometimes you don't know whether it's inside or out, depending on how zoomed in or out you are. But yeah, I have my tool program, so we won't have to go too much of that. But yeah, so then I'm just going to hit start. It's going to run the package, and I think this one did a roughing pass, and then it drops and does a finishing pass. But I don't usually use that. I'll show you when I set up my other one how to specifically do what I'm using. So you can see from here that it's chosen the toolpath for all of these geometries. If we want to actually go in and if we're using, we want to cut the actual disc out too. Add this one, and like I said, you want to choose the outside for the disc cut. And you can see if we go from above, that it's got all of the inside cuts on the inside, and all the outside cuts on the outside. And then if you want to check it, you go right click or double click if you're Mac. Go to simulate. It'll, if there's errors in the program, or if you have it more set up with more in depth and you have a fixture programmed and it's going to crash, or it says your bit's going too deep and the collet will hit, or it's going to ground into your project, it'll give you a little red arrow or red error wherever it's erroring out. But I think this is generally pretty simple where we're going right now. And if you got your right, if you have the right settings, you shouldn't have to worry too much about this. And I know this is really quick. Let it run through the whole thing. I think it'll do a finishing pass on the cut. It's my opinion that once you have the right feeds and speeds, and I have shown from my practice that when you have the right feeds and speeds, it's just one and done, and you get really nice, super nice edge cuts. So we've got that set for this one. Let's go back in. I'll show you the star washer then. And again, I pulled these from my other program just so it's easier to show. But you know, I guess I don't really need to do that. Let's just add another setup. And select the model. We'll go select the star washer. Star washer on. One of my favorite things, well, I guess not my favorite thing, but when you actually have bodies, it says on the sketches, and then it's got bodies. And whenever I'm working, I'm like, oh, I gotta hide the bodies. Get rid of them so you can see your sketch on the bottom. Alright, so we're gonna do another 2D contour. Go back to the top. I believe the feeds and everything's set the same way as it was before. We're going to go to geometry, and we're going to select this. We're going to make sure that it's on the outside. I'm going to select the inside of this one. Make sure that's in. I believe it should be a pretty simple path. And again, you're going to have to pick your feeds and speeds later when I go make another video explaining some of that. If not, you can find tons of this on the internet, where what to find and what to do for specific materials, and you'll have to experiment from there, because I'm still working out stuff with my 6480 as I can't even use the normal mill speeds because it's not rigid enough to do those, and it's going to be a lot of trial and error at this point. So yeah, we got the star washer, machining. Let's go to, and if you want to look at some stats for it, or you want to see what's going on, how long this is going to actually take me. So the star washer for this package is, and I believe that's going really fast. It might need to be slowed down. This is 1 minute to do the full machining, but let's simulate it. And no errors, which is a good thing. And if you zoom in, I believe it slows down to what is the actual speed. Although it does look like it's going almost actual. That's really fast. But yeah, so there you go. You've got the Between the two of these, we've got the tool package and the CAM program for both the star washer and the discs. Pretty simple. From here, you'll end up wanting to export or do the post process. Oh, what's this error we got? Sometimes it'll give you this error and it says there's a warning and it says no model, or that's not a good thing. But sometimes it says something where it's like, oh, your Z depth's going to go down and it's going to go too far past it. And if you know you've got it set up right and it's giving you an error and you know you've chosen the right thing, sometimes you can ignore those. I do it. I'm not saying this is all the time. Don't use this as a rule of thumb. Do this at your own risk, because I have crashed my spindle and made mistakes. But just because there's notes here that sometimes you get the little warning symbol and it'll still work. But be aware of what it's saying as a warning, and because sometimes it won't work. But from here, you're going to, I usually would do these in two separate because they're different operations. Let's go to pick post-process. I'm using Mach3 with my machine. So you just hit OK. It'll ask you to save. And then put it to your jump drive or however you get it to your CNC machine. But yeah, that's pretty much the basics, start to finish, on how to make your first discs, to make the star washers for that disc from your disc pattern, to then bringing it over to your manufacturing and getting your CAM files going, how to post-process it and take it to your machine. And again, once you have the feeds and speeds and everything, this is just rinse and repeat. Pretty simple. Not too far-fetched for the average DIYer to get their hands dirty with. And Fusion 360 is amazing. I really, really like it. I'm not affiliated with anything. I'm just an avid fan. I pay for it now because I've used up the year free that you get. But they've got simulation packaging. I haven't even figured out yet how to use this. You can do animations with your stuff, render, generative design. However, it's a weird credit program you have to pay because you send the program to be run to the cloud and they use their supercomputers to run it, because they are pretty advanced calculations that need to be done to run some of the generative design. But that's their whole business model. But I haven't gotten into the drawing yet. But yeah, the render is pretty cool. I haven't really gotten into that yet, but animation was my favorite, and that's how I've made a couple of the videos you may have seen, my Tesla solar powered video. But yeah, I hope you guys like this. I hope this was useful for some of you guys who are planning on DIYing your own Tesla turbines or getting your own CNC machines, or have your own CNC machine and want to know exactly how to go about doing your own Tesla turbine. There are a lot of other CAD programs you could be using. I'm not even going to go into the list of them. This is what I use. I find it really simple, and it's got a very powerful platform to use. You can get into turning, additive. I believe, I've been told, I'm not really too much into 3D printing yet. I've been told it's becoming the standard that a lot of 3D printers use. You can slaughter me in the comment section for making such heretical statements if I am completely wrong. But yeah, I hope you guys enjoyed this. Take care, everyone.